In section 5.2, we're considering measures of center and variation for our discrete probability distributions. The mean of a discrete probability distribution has a different formula from our previous formulas for mean. We're going to add up x times p of x. So we'll multiply x times p of x first, and then add each one of these multipliers together. So the corresponding values of x times its own probability. So we'll multiply first and then add them all up. And I'll show you an example shortly. The variance for a discrete probability distribution has a formula that's similar to our mean. Remember that standard deviation and variance are average distances away from the mean. So that's why we have that mean in there. I've included this second alternative formula down here just to show you that it exists more than anything, and that it's related to our formal definition for a general data set. But computationally, it's much more difficult. So statisticians took this formula, did some algebra on it, and created the easier formula that we will use above. So we're going to primarily focus on the bigger formula instead of the smaller one. They mean the same thing, but if we're going to do variance by hand, we're going to use the first formula. We have to be able to calculate the variance in order to get the standard deviation, because the standard deviation is the square root of the variance. So we'll need to calculate the variance first and then take the square root. Something to notice about all of these, they are all population parameters. Population parameters are also known as theoretical parameters. And so that's why we see these Greek letters of mu and sigma squared. Just like before with our measures of center and measures of variation, we have a rounding rule. And that rounding rule is that we are going to round the mean, the variance, and the standard deviation one more decimal place than the outcome, x. X is representing our data. The probability just tells us how frequently that data value is going to occur. So these values for mean, variance, and standard deviation, they are summary values for the outcome x. So we round for one more decimal place than the outcome x. Now, x is a discrete random variable, but in the instances of money, we may have 2 decimal places because we can count cents. So if you're working with a discrete random variable dealing with money, then your mean, variance, and standard deviation will have 3 decimal places instead of 1. One more measure that we get with our discrete probability distribution is that of expected value. Expected value, also known as expectation of a discrete random variable, is the theoretical average of the variable. Oh, wait a minute. That just means that the expected value is the mean of our probability distribution, and we have the exact same formula for our mean as we will for expected value. So if you see that word expected value or expectation, link those words with the mean. They mean the same thing. Expected value or expectation is the mean of the probability distribution. Okay, let's find the expectation or the mean of the probability distribution that we did in the previous lesson. So in that lesson, we had a probability distribution, 5,000, 7,000, 9,000, and the probabilities associated with that, 1/2, 3/8, and 1/8. So to find the mean or the expected value, we're going to multiply 5,000 times 1/2 plus 7,000 times 1/8 plus 9,000 times, 7,000 times 3/8 plus 9,000 times 1/8. Notice in this example that if we add our probabilities together, 4/8 plus 3/8 plus 1/8, we're going to get 1. All of our probabilities lie between 0 and 1. And to find our mean, let's grab our calculator. So calculating our mean, 5,000 times 1/2 plus 7,000 times 3/8 plus 9,000 times 1/8. And we get 6,200. $6,250 for our mean. Essentially what this means is if we were to repeat this process over and over and over again, on average, we would expect to make $6,250 as a return on our investment. Notice it's really close to 5,000 because my probability for 5,000 is 1/2, much higher than the others. But the other probabilities pull the average away from 5,000, making it a little bit bigger. Okay, so we have our variance and our standard deviation formulas here. We're going to use these to find the variance and the standard deviation on exactly the same probability distribution that we just did. So we're still using that same probability distribution that we had before with the investments. And I'm going to flip my table. So instead of being horizontal, I'm going to create it vertically. And the main reason for this is so that I can make a bigger table to the right and get all of the pieces that I need to calculate the variance. So there's our probability distribution. I'm going to make a little double bar here. And in my formula, let's keep the standard deviation up. The variance that we're going to calculate is what's underneath this radical. So we're going to do that first. And recall that the mean that we just calculated was 6,250. So we need to calculate x squared and then x squared times p of x. So we'll first start out by squaring the x values. 5,000 squared is going to be 25 million. 7,000 squared is going to be 49 million. And 9,000 squared is going to give me 81 million. Feel free to use your calculator if you need to. And then x times p of x, x squared times p of x squared times our probability. And we'll use these values to calculate our standard deviation and our variance. So let's start out with our variance. Sigma squared is the sum of x squared times p of x minus mu squared. So we're going to do the sum first and then subtract mu squared. And so we end up with 41 million, and then we're going to subtract the square of 6,250 minus 6,250 squared, and we get 1,937,500. So our variance is 1,937,500. This would be in square dollars, which is weird, so we leave the units off for our variance. To calculate our standard deviation, we're just going to take the square root. So in our calculator, take the square root, we get 1,391.9 dollars for our standard deviation. In the next part of our lesson, we'll take a look at finding these measures using technology.